Good afternoon. As the slide says, I'm the Central Coastal California Seismic Imaging Project Technical Manager, which I've quickly learned means that I have to worry about pulling permits, balancing budgets, and herding cats. So it's nice to be able to spend a couple days here with you all and talk about science for a change. What I am going to talk about this afternoon is just kind of briefly review some of the seismic source characterization sensitivity results that Katie Waddell talked about yesterday morning that we keep hearing about in terms of trying to, again, understand what matters, and then bring you up to speed on the surveys to date that we've done for this seismic imaging project offshore, and then what we're looking at for doing future surveys into 2011 and 2012, and then finally spend a little bit of time looking at this idea of a legacy archive that Sirkin has brilliantly described for us this morning. So think of me as a sort of the introduction to many of the talks that you're going to hear later on this afternoon. So as you saw yesterday morning, in terms of what really matters, this is a tornado diagram whoops, sorry about that. This is the tornado diagram that Katie had put together. And you know, the parameters that matter for doing the PSHA are things like slip rates on all these major faults and geometry. So these are parameters that, you know, the geophysics that we talked about this morning, the gravity and magnetics, as well as seismic reflection, are very powerful tools in order to help us understand the geometry of these fault zones, these fault systems, and then also, you know, looking for potential piercing points, recent geologic features that cross the fault zones that we can use to get ideas about what slip rates actually are. So kind of put this in context in the work that we're going to be talking about a little later this afternoon. But to start off with, there's been a lot of improvement in geophysical data acquisition over the last 20, 25 years since the original LTSP. So we've seen improvements in geophysical instrumentation, better signal-to-noise ratio in the data that we're collecting, as well as data processing, being able to just pull out signal from all that hash that we collect. Differential GPS navigation. We know where we are now to an unprecedented level of detail than we ever did before. And as you saw this morning, again with Sirkin's presentation, you know, the use of geographic information systems to visualize the data that we're collecting and then being able to integrate it and compare it with other data sets has really been a revolution. What we've also seen and what we're able to do now over what was available 20, 25 years ago is go from this idea of taking X-rays of the crust of the Earth to doing CAT scans. To go from 2D seismic profiling to now this whole era of 3D seismic profiling. Again, the idea, just like you go to your doctor's office with this CAT scan, you can look at it at different angles, rotate it around, get true dips instead of apparent dips, and all these parameters we couldn't do during the original LTSP. So all this has led to what I call the revolution in resolution. And we kind of move forward, kind of thinking about how we can take advantage of this to address and answer some of these data needs that we're talking about here at this workshop. So this is the area for the seismic imaging process that goes from, you can't really see that, here we go. That goes from San Simeon up to the north all the way down to Point Sal. Diablo Canyon is here more or less in the center. Some of the major fault zones, here's the Hosgri, the shoreline fault zone here. So this is the area of primary interest as part of the studies that we've been doing. And to date, we've managed to finish two principal studies. The first is a 2D, 3D low energy study off of the northern segment of the shoreline fault zone here off of Point Buchan. And then the second is a very intensive 2D, 3D onshore shoot at the Irish Hills and the Los Osos Valley. Number two is to get an idea about what the structure of Los Osos fault zone is and some of those major faults onshore, which up until now really haven't been imaged as well as a lot of the offshore work that's been done in the past. So this is just some shots of the survey area and doing the actual survey. For this low energy survey, Again, what we were able to permit, given current California rules and regs, is basically a low energy, about 2 kilojoules or less, equivalent to about a handful of firecrackers in terms of power or size. And what you see here behind the back of the boat is this triple plate boomer that we used, and then a number, basically 4 streamers, 50-meter streamers behind the boat. One of the challenges that has been discussed already this morning, and that certainly comes up with any of this marine work, is the intertidal zone and the transition zone, because you have lots of rocks within that first kilometer from the shoreline. You have kelp beds and loads of other things that really impede the ability for large boats to go in and do significant amounts of imaging. What we did here with this low energy study, this is a relatively small boat. It's about, what, 50, 60 meters. So even that, you know, it was kind of white knuckle getting in there and moving around some of these larger rocks. And the boat that Rick Vitek used, for instance, for his multi-beam work, was, you know, about 40, 50 feet. So smaller boats you can do it, but larger boats for high energy surveys, it's just not going to happen. This is a picture of the track lines that we collected for last winter's survey. And what we accomplished was about 2,000 line kilometers of 2D, 3D data. The 2D data cube is outlined here in the yellow, that T-shaped box. So that is an area of about 17.5 kilometers, and that was basically set out to look at this intersection of the northern segment of the shoreline fault zone with the Hosgre Fault. What happens is, to the south, we can see very clear, you know, bathymetric geomorphic expressions of this feature that we call the shoreline fault zone, but it dives underneath the sand layer that's up here to the north near Point Bouchon. So geophysics is essential to be able to peer beneath that sand layer and see what that surface expression is, and then also what it looks like here as it intersects with the shoreline fault zone. So in addition to doing this 3D survey, we also conducted an additional set of 2D lines, which are shown here in the black track lines at about 100-meter line spacing. So of that, we've processed so far about 335 line kilometers of that data as well. And this represents an unprecedented data set in terms of the level of resolution and detail that we have for this part of the margin. Phil Hogan is going to talk a little bit more about this later on this afternoon. In addition to the offshore work last year, we've also done a significant amount of onshore work, 2D, 3D work in the Irish Hills and the Los Osos Valley, right around where we are sitting today. And this is just some shots of the Vibra-sized trucks and the accelerated weight drop trucks that we used to conduct those studies, again, to get penetrations down to 10, 15 kilometers, or basically as deep as we potentially can, with the Vibra-sized trucks, and then with the weight drop trucks, kind of using that as a high-resolution survey tool for more shallow penetration, maybe down to the top 5 kilometers. But the conjunction of the two, again, gives us some unprecedented imaging of the area. This slide shows the survey routes that we have conducted this fall. In fact, this week we're in the process of finishing up those routes. Dan O'Connell is going to tell us much more about this later on. But in summary, we surveyed about 120 miles of route throughout the Irish Hills. Previous work that had been done in this area before just basically went through the center of the Irish Hills and just kind of nicked, you know, the surface of what that structure was beneath the surface. So we wanted to go and do a much more comprehensive survey of the area. And what you see here, again, in the solid lines are the survey routes for both the Vibra-size and these accelerated weight drops. And along these routes, we ran cables as well as nodes. And nodes, for those of you not familiar, are these coffee can-sized autonomous seismometers. You can just plant and leave for a period of time, usually about 2 weeks of the battery life. In addition to running that instrumentation, this dense collection of red that you see here in the center of the photograph was an attempt to create a quasi-3D survey. So really get high-resolution imaging of the Los Osos fault zone here towards the top of the figure as it's dipping towards the south. Again, to get a better understanding what the geometry of the Los Osos is. So Dan's going to talk a little bit more about that later. Moving into the end of this year, into next year, there are 3 projects that we have either going to do or are proposing to do. The first is another low energy survey down here off of Point San Luis to chase the southern end of the shoreline fault zone. We've spent time now looking at the intersection of the northern part of the shoreline as it goes into the Hosgri. Well, what happens to the southern end as it goes into San Luis Bay? The second project is to look in more detail at the San Simeon Hosgri stepover, which was discussed yesterday, again, as being an area of concern and need of more work, and kind of complement the work that Sam Johnson and the folks at USGS have already done in that area. And then finally, we wanted to go and we're proposing to do this high energy seismic survey, or HESS survey, which is going to be involving air guns and basically try to get us deeper crustal penetration along the whole continental shelf here to complement the shallow, low energy work that we've done to have a better image at top to bottom of what the crustal structure looks like in the area. So this is a topographic, well, actually a contour map of a paleo channel that we discovered last year as we went out and did some preliminary survey work in Avila Bay. And this paleo channel is the ancestral drainage for San Luis Obispo Creek that cuts across what we think is that southern extension of the shoreline fault zone, which is shown by the dashed lines here. And so the idea is that this paleo channel could be a potential piercing point. And looking at that, we can get information about rate on the shoreline fault, which is one of the critical parameters we need for the PSHA, as well as getting a better understanding of where the southern end of this is. The 2 lines down here are extensions of the Pecho fault, and so whether the shoreline fault comes in, intersects the Pecho fault, parallels it, or what that source geometry looks like is some of the targets that we're going to be looking at next month in December as we go out with that. And the text over here on the left is just a description of the kit that we're going to be using on the boat. Yeah. Last year we used 4 streamers. This year we're looking at running what's called a P-cable system, which is 12 to 18 50-meter long streamers to, again, get high-resolution 3D coverage of the area. Later in 2012, what we're going to do is go back to the stepover between the San Simeon Fault, which is up here near Point San Simeon, and the Hosgri Fault. So the area between Estero Bay and San Simeon, and get a better understanding of what the geometry of that stepover is. In the original LTSP, it was postulated there was about a 3-4 kilometer stepover between the San Simeon and the Hosgri. More recent interpretations tend to suggest that maybe, in fact, this is a continuous feature between the San Simeon and the Hosgri, but nevertheless, it is an important feature for the PSHA in kind of understanding what the seismic hazard is and the seismic potential for that particular area. So in this case, we're looking at doing a 2D survey as opposed to a 3D survey, but it's going to be very, close line spacing on the order of about 100 meters. And then again, looking at more high resolution shallow as well as a little deeper penetration. Finally, we're in the process right now of getting the permitting to do high energy seismic survey here along the coast of California. This is something that hasn't been done for at least 25 years. And this is one of the things I talked about in the beginning about my job is pulling permits. A lot of environmental impacts, a lot of environmental consequences that we've had to address in order to pull the permits to use air gun arrays. So this is the kind of energy that you need to penetrate down to depths 10, 15 kilometers in the crust and start answering some of the questions about crustal structure at seismogenic depths. So what we're looking at here is using the Columbia University boat, RV Marcus Langseth, that is owned by National Science Foundation and run by Lamont Doherty. And they have 3,000 cubic inch air gun array, and they run 4 6-kilometer long streamers, which are going to give us a group interval or a bin size of about 6.25 meters by 50 to 75 meters to image into the upper crust. In addition to running seismic as part of their normal operating procedures, we also look at running gravity and magnetics as well. And so as we survey the continental shelf in this area, we'll be able to add to those databases and fill in where some of that stuff just wasn't available up until now. The figure here on the left is the racetrack diagram, or the ship tracks, that we originally were proposing before we actually engaged the Langseth to give the folks at the State Lands Commission an appreciation for the scale and the magnitude of this kind of project. The figure here on the right is that same racetrack, but now what we've done is more closely identified exactly what the targets are that we're going to look at. And again, a logistical issue, getting close to the coast, dragging a 6-kilometer long streamer behind the boat really requires that the racetracks are going to be running parallel to the coast. Ideally, you want to run these things perpendicular to structure, but you can only do what logistically you're able to do. But here in Estero Bay, we figure that it's going to be possible for us to run tracks perpendicular to structure and get a better understanding of what the geometry is in this particular area. And we talked about earlier today, you know, the attitude of faulting as it comes out of Los Osos Valley, how those faults hook up with the Hosgri is of critical importance. The other issue is looking at this transition or intertidal zone. Parts of the shoreline fault zone are within that 1 kilometer zone from the shoreline where there's kelp, shallow rocks. So what we're planning on doing is running a series of transects perpendicular to the coast using these marine geophones that will be positioned on the seafloor and shooting to those geophones using both onshore vibra-sized trucks as well as offshore air guns from the Marcus Langseth. So this is something that Walter Mooney talked about a little bit earlier this morning, and kind of anticipating but not knowing that this is what we're thinking about doing it. So here the idea is to be able to straddle the shoreline fault zone in those areas where you just can't reach it easily with a marine operation. And then finally, the Legacy Data Archive. Sirkin talked a great deal about this morning. Some of the other talks this afternoon, starting with Walter and Sam Johnson, are going to kind of fill in the detail of data that have been collected in this area over the last 25 years. All of this which we want to pull together and have it available as a resource moving forward to continue doing the work. So thanks for your attention.
Thanks, Stu. Any comments or questions for Stu?
I have a question. Do you have an updated probability of getting permits for the high energy survey at this point?
We're steadily moving forward on that process, and right now the schedule is that environmental impact report is going to be released for public review most likely in January. So the way the process goes is, you know, the State Lands Commission hires an independent third party to write the environmental impact report. It goes out for public review, then it gets evaluated, and then the recommendations from the Lands Commission go to the commissioners about whether or not to issue a permit or in what conditions under which that permit will be issued. So far everything has been moving forward, and we have been, again, you know, taking great pains to make this as environmentally friendly as possible.
And the source that you've been discussing is a 3,000 cubic inch source, is that right?
Yeah, 3,000 cubic inch air guns.
And how does that size source compare to what was done 25 years ago? And
well, Jan Reitman will talk a little bit more about the original LTSP surveys, but back 25 years ago, some of those sources were 6,000 cubic inches. So we're half the size, but again, you make up for the reduction in size by improvements in data processing capabilities, as well as, again, doing this 3D work as opposed to running single streamers behind the ship. So being able to clean up the images more effectively and overcome the limitation by using smaller sources is our hope we can do this.
Hey, Stu, I have a question. Just getting such a program going, as you were just commenting, it takes someone like you, takes a lot of effort, long lead time permitting, long lead time funding, all of that. So this is, you're well underway. What are the opportunities to make slight revisions to the program based on sort of issues or comments that come up out of this session? Can we redirect the ship over into Estero Bay and collect some data?
Well, I would say it's not cast in stone yet, because, the time where things were going to get cast in stone is once that environmental impact report, the public comment period closes, we go into negotiations and look at alternatives based on those public comments, we kind of address everything and start fine-tuning. And we've always, felt that until we actually engaged a ship, in this case the Langseth, we wouldn't be able to really understand what the capabilities of the boats were. Okay. So a lot of this has been preliminary, conceptual, and now it's converging to what the actual survey parameters are going to be. So the short answer is yes, I think there is opportunity to fine-tune this based on what we've been talking about. And one of the things I didn't pull up is, we want to go into Estero Bay. We are not going into Avila Bay or San Luis Bay, and while, the faults in San Luis Bay are not judged as significant for the PSHA because of their distance from Diablo Canyon,
yeah,
they are critical in terms of understanding regional context and what we're dealing with, and some of the things that Catherine was talking about, buried shorelines, terraces, and things like that. So if you're out there, it's such, as you said, time and effort to mobilize, to spend a couple extra days and go shoot some more lines. Seems to be an efficient way to go doing this.
What about, we heard earlier, for example, and this is just an example to get a feel for it, Bill Page mentioned if we could identify a target where we might have a channel crossing the Hosby Fault and then go out and collect some very high resolution chirp data,
right?
3D chirp data or whatever. Does that fit into your program anywhere, or is that something that can be added to a program very easily, or what happens? How do we respond to Bill's request?
You certainly can do that. I don't think the Langseth necessarily is the boat that you want to use to go and collect chirp data. You can use a lot of the smaller boats that we've used last year instead of this 300, 400-foot boat with all the kit behind it. But that is sort of separate and distinct task from what we're talking about here for the high energy. Yeah. But in terms of the overall marine investigations, sure, why not?
I guess that's what how do we, okay, the answer is then, sure, why not? I like that. I'll leave it at that.
Yeah. The key thing here
I guess that's what I wanted to hear.
Yeah, the key thing here is permitting. As Neil will understand, high energy work takes months and months to permit. Low energy work is, a lot of the contractors that we work with already have low energy licenses and permits. So running, these triple plate boomers we were talking about, or chirp systems, is relatively easy to mobilize. It's when you try to do the high energy work that you're looking at a time period of 2 years that it gets much more difficult. So that's what I mean. The low energy stuff, it's really just a matter of identifying a boat, a budget, and a crew to go and do it.
I have one other question about the track line. I know you've spent a lot of time trying to get creative with people and try to really see if we truly are forced to go with the racetrack that's parallel to the coast,
Right.
which is not favorable in that it's parallel to the structure as well. Is there any more recent developments with assurance that, given this structure parallel racetrack, we'll still be able to resolve these structures, or does the Columbia ship, does the Lamont Doherty ship have any new creative ideas of how to process the data such that we can do a better job?
There are things that you can do to kind of overcome the limitations on how you run the ship. And one of those is the spacing between the individual streamers. So, you know, right now we're looking at spacing 100, 150 meters apart. You can bring those streamers closer together to get, again, more dense sampling along the ship track, or alternatively, what you can do is go one way, turn the boat around, and then go in between the tracks of that previous run. So in essence, you've now have the spacing between the streamers, so that'll give you higher density sampling. So when you want to reorient your section to be a dip line instead of a strike line, you'll have more data to work with to do that interpolation. So it's not a showstopper. Ideally, you'd want to shoot dip lines, but you know, we can only do what we can, given the tools we have to work with.
Okay.
Yeah, thanks, Stu. That was great. When you referred to high-energy work, I thought you were talking about Lloyd Clough for a minute there, but now I understand. A couple of questions. It's good to hear that you can modify the plans a little bit based on these discussions. That's great. And for the Langseth, as I recall, Lamont, you know, has a schedule. They have to be at a certain place at a certain time. So my question is, do you have an alternate plan in the event that by the time you get the permit, the Langseth, they could be over in Australia or someplace?
Well, the target for us engaging the Langseth is going to be next fall. So basically from September 1 into November. So again, we're already in negotiations with those folks. They've set aside that period of time, and we have, I wouldn't say assured, but the permitting agencies are also aware of these scheduling issues that we have to deal with. I have to say too that, you know, the Tohoku earthquake has really placed a lot of pressure on us to do this work, as well as political pressure to collapse or accelerate the typical schedule for doing these kind of permitting activities. So we went into this, you know, more than a year ago thinking it was going to be 18 months to 2 years. Due to the emphasis, the importance of this project, you know, pressure is being placed to kind of collapse this down to less than a year to actually go through all the EIRs and get the necessary permits issued. This is not to say it's been the easiest year for a lot of us, but there is a recognition this is a high priority.
Another comment is that, had you thought about recording the air gun on land with portable recorders? Because it's going to be strong enough to be recorded, and there'll be a lot of shots. So land recorders would give you the
Yes,
bridge.
and let's see,
Maybe
let's
I
go
missed
back
that.
here for a second. I kind of started running out of time here, but the idea is
No, we're
that in addition to having these marine geophones in the offshore, what we do is put these nodal systems onshore and basically have ray paths going from onshore to the offshore, as well as ray paths from the air guns offshore being recorded onshore. And then this would also augment the onshore work that we've already done this year. So it makes for a nice tidy package. But again, the idea is that since this is such a difficult zone to work in the intertidal, we're trying to optimize the data collection as best as we can.
Excellent. Other comments for Stu? And a lot of the subsequent presentations were building on a common theme. A lot of seismic reflection data will be presented in the next few sessions. One thing that Stu mentioned was schedule. And I just wanted to comment, this is mainly the benefit of our TI and PPRP. We have in our project program plan, the SHAC program plan, a schedule which attempts to show the interface between these ongoing programs, including the seismic, the HES 3D study and some of the other seismic studies, as well as some of our onshore geologic studies. And I've tried to lay that all out in our project schedule. I will be updating and tweaking that as we go forward because schedules are changing right now. And so I'll be reissuing the schedule to the PPRP and to our TI team, trying to keep it current as much as I can, but it'll just mean I'll have to keep sending out some